Okay, so this is part 2 of the video, and I wanted to pick up where I left off before in solving this problem. So what we've done is we've changed cosine 2x to cosine squared x minus sine squared x, and then changed sine squared x to 1 minus cosine squared x. And that gives me 3 cosine squared x minus 3 plus, because that negative and that negative makes this positive cosine squared x, minus 5 cosine x equal to 1. Cleaning this up and setting it equal to 0 because it's quadratic gives us 6 cosine squared x minus 5 cosine x minus 4 equals 0. And I want to talk a little bit how to factor this using guess and check. So I have to think about what two numbers can I multiply to get 6, where the first is 6x and 1x. Okay? What two numbers can I multiply to get 4, where I can either try 4 and 1 or 2 and 2. So if I try 4 and 1 here, I get 6x and 4x, and I need a combination to get that to be negative 5. One of them is positive and one of them is negative because this is negative. So there's no combination that I can use, because this would be 6x and this would be 4x. There's no combination that I can use to get minus 5 in the middle, because 6 minus 4 is 2. Okay, so negative 6 plus 4 is negative 2, so there's no way to get 5 in the middle. Okay, so that doesn't work. So then I could try, leaving the 6 and 1 there, I could try 2 and 2. Okay, if I try 2 and 2, that gives me 12 and 2. So there's no combination that will give me 5. So 6 and 1 is not working. So let's try, the other combination to get 6 is 3 and 2. So let's try 3 and 2. So if I try 3 and 2, I get 6x and 4x. Again, there's no way to get a 5 in there, because I have to subtract them, so 6 minus 4 is going to give me 2. So that doesn't work. So now I can try 2 and 3. So if I make this 2 and this 3, I get 4 and 6. That doesn't work either, because I still get 4 and 6. That's still going to give me 2. So that doesn't work. So I can try 2 and 3 with 4 and 1, or 1 and 4. So let's try 1 and 4. That'll give me 8 and 3. Hey, that works. So if this is 8 and 3, that'll give me 5. I need the 5 to be negative, so I need the 8 to be negative, and this will be positive. So if I multiply this out, this gives me negative 8 plus 3x. If I add that together, I get negative 5 in the middle. So that is my solution. That's how I factor that. So then I get x, in this case is cosine, so I get cosine is equal to negative 1/2, and cosine is equal to 4/3. Now, I don't have, this is not on the unit circle, so I can just write that x is equal to the cosine inverse of 4/3. And that's a perfectly good answer, since that's not on the unit circle. Then cosine x is equal to negative 1/2. We'd have to find the unit circle and see where is cosine x is equal to negative 1/2. That would be in quadrants 3, 2, and 3. So it's equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. So then my answer for this one would be 2 pi over 3 and 4 pi over 3. Okay? One more, and we'll call it a day. You can do the other two at home, and then we'll work on that free response problem in class tomorrow. So cosine 2x plus sine x, again, I have to change this cosine 2x to cosine squared x minus sine squared x plus sine x is equal to 1. Once again, I want to get everything in terms of cosine, in terms of sine, because these two are sine. So I want to get everything in terms of sine x, so this becomes 1 minus sine squared x minus sine squared x plus sine x is equal to 1. So that's negative 2 sine squared x plus sine x, and the 1 minus 1 becomes 0. So then for this one, I can factor out a negative 2 sine x, and I get sine x minus 1. So I get sine x is equal to 0, or sine x is equal to 1. So sine x is equal to 0 at 0 and 2 pi, but I think it's being solved from 0 and 2 pi is not included in the solution. And sine x is equal to 1 at pi over 2. Is that right? I think that's right. It's not. Okay. All right, so that's how we solve using equations. We will practice this some more in class for belt work.